Modern AI and traditional cognitive interventions share a severe structural limitation. They rely on opaque hidden layers. This black box generates unverifiable chains of thought. In neuroscience, the prevailing model is known as rebus. Its objective is to passively relax cognitive priors and minimize free energy, placing the brain in a state of quiet surrender. Neurosoft replaces this passivity with a demand for active, precision-weighted interference. To aggressively rupture these inaccessible cognitive boxes, the Neurosoft system deploys a mechanism called Recursive Vector Interference, or RVI. The overarching architecture that controls and directs this collision is the Causal Thought Mapping System, the CTMS. The CTMS treats human and machine reasoning as a formal lambda calculus software pipeline. Achieving clarity requires a compiler for the mind, a protocol that translates chaotic insight into executable syntax. The architecture relies on a single tokenization equation: thought tree, traverse, flatten tree. This is a roadmap of the CTMS compiler. It shows how an abstract idea is forced into a linear, auditable stream. It begins at the seed node. This is the initial token embedding of an idea into a one-dimensional stream. The seeded token then moves to the bloom node, where it undergoes feed-forward expansion to build a broader thought tree of possibilities. Next is the fork node. This acts as an internal self-audit, where the system asks if it can logically explain its own expanding output. If the answer is yes, standard narrative resolution carries the data to the flattened stage. If the answer is no, the system reaches the crisis point, where standard cognitive models typically fail. This failure triggers the recurse node, which deliberately forces a crash of the cognitive loops to break the impasse. While standard AI architectures stall at this fork, the CTMS leverages the wreckage to generate a new mathematical synthesis. Inside the recurse node, the system activates the Recursive Vector Interference Engine. This software mirrors a biological reality, the collision between asynchronous neural loops, specifically the prefrontal cortex and the default mode network. The mechanics of this collision are governed by equation 2, the coupling functional. It measures the phase alignment of these colliding loops at a target hub. When the phase offset is orthogonal, the collision produces energy without work. It generates heat and noise, but no structural results. However, when the timing constraint accurately aligns the phase offset near zero, the peaks synchronize. This moment of constructive interference forms a stable, load-bearing cognitive ridge. This process replaces the global precision reduction used in older models with selective, localized precision weighting. The timing constraint turns raw white matter anatomy into a functional, highly specific logic gate. This constructive interference bridges the gap between chaotic conceptual thought and strict, structured logic. RVI acts as a precision engineering tool, colliding waveforms until they produce sustained physiological change. Managing those biological ridges requires a rigid software architecture. This is the role of the Play Intergalactic Calculus Engine, or PICE, the backend that executes the CTMS logic. PICE utilizes a mathematical syntax built on core lambda combinators. It replaces hidden thought with an explicit audit trail. The next thought operator forces the system to advance sequentially along a single logical branch. The split branch operator deploys parallel, simultaneous explorations of competing concepts. When the system detects a breakthrough ridge, the transcend operator allows it to jump abstraction levels. Navigating these collisions carries the risk of infinite loops and system paralysis, a state known as recursion sickness. To manage this, the PICE module uses the Gödelization operator as an emergency failsafe. Gödelization embeds self-reference to surface deliberate paradoxes, probing and safely breaking undecidable loops. This suite of operators allows the CTMS compiler to safely ride the chaotic energy generated by the RVI engine without breaking down. The PICE module translates theoretical neurobiology into an auditable language, proving that recursion is a functional tool, not a system failure. This leads to the final step of the CTMS pipeline, the flatten stage. This structural map is the CTMS disintegration ritual. On the left, raw thought enters the pipeline. In the center, the RVI engine forces asynchronous loops to collide. Finally, the pipeline delivers its flattened output, a structured psycholinguistic result. This output is Neuralese, A biomimetic programming language generated directly from physiological and neural phase geometry. Neuralese translates these matrices into stories, rewriting cognitive priors as executable code and bypassing the opacity of traditional AI. The CTMS architecture enables a transparent, auditable integration of human and machine minds by treating recursion as a functional, measurable tool.